Okay, so let's take a look at 17F and 17E and 17G. First thing is something called boundary conditions. Very straightforward. The idea is, the idea here is, for example, I tell you that the derivative is x squared. And the question is, what was the original function? The problem, though, is you don't really know because there's a family of functions. You know that taking the integral of both sides gives you 1/3 x cubed plus c. And so you look at the graph and you say, you know what? I don't really know. I don't know which one it is. Is it is it here? Is it here? Is it here? So you're not really sure what the function is. So you need a boundary condition. Algebraically, we see here we have y equals 1/3 x cubed plus c. We have three variables. So if I'm given a point, I can substitute it into the equation and I can find my c. So the question would be, given that dy over dx equals x squared and y passes through let's say how about we say 9, 7. No, not 9, 7. Sorry about that. How about 2, 7? So you find y, and you say, okay, well, I have my function, my derivative. Therefore, I integrate. I have 1/3 x cubed plus 1/3 x cubed plus c. So y equals 1/3 x cubed plus c. I have 7 is equal to 1/3 2 cubed plus c. I have 21 over 3 is equal to 8 over 3 plus c. So c is equal to 13 over 3. Final answer, y is equal to 1/3 x cubed plus 13 over 3. That's the idea of a boundary condition. Try this one. Find y if dy over dx equals 2x plus 3 and y passes through how about -1, 11. Okay, pause the video, take a moment. Okay, we're back. So we know the function, we have the derivative, so we know the integral, we know the original function is obviously a quadratic, and so we know it's a parabola that passes through the point -1, 11. So we know that the integral of 2x plus 3 dx is equal to x squared plus 3x plus c. You have to put the c in, or you're going to lose a point. I don't make up the rules, IB does. We know that it passes through 11, -1, so we say that 11 is equal to -1 squared plus 3 times -1 plus c. Let's see, 11 equals 1 minus 3 plus c. c equals 13. Final answer, what is it? Final answer, y is equal to x squared, plus 3x plus 13. Okay, let's move on to the next unit, which is definite integrals. Now, we really haven't spoken about exactly what's going on here. And you kind of know that integration is connected with area under the curve. So we're moving towards that, but we still just want to do the basic algebra of definite integral. So, I'm sorry. So the idea is, if you're given the integral, right? If you're given the integral from a to b of f of x dx, right? So what you're going to do is you're going to take the integral. So, and let's say that, and also that there's this function f of x, the derivative is our original f of x, right? Then this is equal to f of big B. So you're going to take the integral, which becomes big F of x, and you're going to plug the b in, and then subtract off the a. What we're going to see is this is our lower bound. This is going to be our upper bound. What we're going to see is that we're going to have a curve, f of x. I'm going to give you a lower boundary of a. I'm going to give you an upper boundary of b, and this process of integration will tell us the area under the curve. But for today, we're just doing the algebra. So if I say, what is the integral from 2 to 6 of x squared dx, you say, okay, x cubed over 3, big line, 6 to 2, you say 6 cubed over 3 minus 2 cubed over 3, 216 minus 8 is 208 over 3. Mr. Adler, you ask, what happened to the c's? Well, the idea is this kind of was like a c was here, and then there was you subtracted another c here, the c's cancel out. So when we're doing definite integrals, we no longer need the c. So that goes. And this is how we find the definite integral. Once again, it's going to be connected with the area under the curve, but you could get weird answers. So once again, we're not going to talk, you're just going to do the algebra. Okay, let's pick another example. How about the integral of, I don't know, let's see, 2 to e of 1 over x dx. Well, you've been practicing, you know this stuff. So, what's the integral of 1 over x? Okay, it's ln of x from e to 2 to e, sorry. So it's ln of e minus ln of 2. Final answer, 1 minus ln of 2. You need to know your e's. They might say e squared, e cubed. They like that stuff. Let's try another one. How about the integral from pi over 4 to 3 pi over 2? Well, let's make it pi of sine of x dx. Actually, well, let's make a cosine, because I'm not in the mood for negatives right now. Okay, well, what's the integral of cosine? You say, okay, it's sine of x from pi over 4 to pi. So we have sine of pi minus sine of pi over 4. What's the sine of pi? 0. What is the sine of pi over 4, 45? Radical 2 over 2. We get negative radical 2 over 2. Once again, with the algebra, strictly divorced from an application, we get negative numbers, and we're going to talk about where the negatives show up. Because once again, you're saying, well, how could it be the area of the curve? Let's hold off on the idea that this is the area under the curve. It kind of isn't. So, but you're just going to do the algebra. And then, obviously the book is just going to give you like algebra problems. So you know, you might see something like, you know, the integral from, I don't know, 2 to b of, you know, x squared dx is equal to 17. Let's say find b. And this is, it's just an algebra problem. I'm not even going to solve this. So, that's it. Work on 17f, work on 17g. In the next class, we're going to talk about the geometric application of integration.